Question number 6 is vectors. Vectors is a line with an arrow. So we have two lines. So this is L1, this is a line, and this is L2, this is another line. So it's a line with a direction. So to show that two lines intersect, you have to understand that this constant lambda, this refers to a particular point on the line L1, and the point mu refers to another particular point on the line L2. So to show that L1 and L2 intersect, you have to show that whatever value of lambda is and whatever value of mu is, the point on L1 and the point on L2 is such that they are here. So we have to find both the values of lambda and mu. So the first thing that needs to be done for doing this sum is to express this as the position vector rule. So let me write down L1 as r equals to, so this is minus 9i plus lambda into 2i, so minus 9i plus 2 lambda, and I'm taking the I common, plus there's no j here, so I'm going to write here 0, plus this is lambda into j, so j, so if I take j common, it will be 0 plus lambda. Now we have 10k here, so this is 10k, and this is lambda into minus k is minus lambda. If I take the k common, so it will be this. So this is L1. L2 here, we have 3i here and 3 mu. If I multiply this constant here, so 3 plus 3 mu I. I have j here and minus mu j here, so 1 minus mu, and I have a j. I have 17k here and mu into 5 is 5 mu, so this is 17 plus 5 mu k. So that's what we have here. Now to solve this, you have to understand the point has to be in the same position. So that means this and this should be in the same position, this and this should be in the same position, and this and this should be in the same position. So we can write for I equals to I. Please remember to underline the vectors. It's an essential part of this sum. If I say I equals to I, then minus 9 plus 2 lambda equals to 3 plus 3 mu, and we can have this equation written out like this: 2 lambda minus 3 mu equals to 9 plus 3 is 12. So this is equation 1. Next, for j equals to j, this is 0 plus lambda, so 0 plus lambda equals to 1 minus mu, 1 minus mu. So this is going to be lambda plus mu equals to 1. So now we have to solve this two simultaneous equation. Remember, we have to show that the two lines intersect. So for that reason, we have to find both the values of lambda and mu. If we have to just find the point of intersection when it is given that they intersect, either one, lambda or mu, would do. But here we have to show that both lie at the same position. So to solve this, I want to multiply this with 3 so that these two cancels off. So multiply it with 3. So the first is going to be 2 lambda minus 3 mu equals to 12, equation 1. 3 lambda minus 3 mu, equation 3, equation 2. Now if I cancel this off, this thing and this thing cancels off. 2 lambda plus 3 lambda is 5 lambda equals to 12 plus 3 is 15. So therefore lambda equals to 3. So that is the lambda is like this. Okay. So that is the value of lambda. So mu is going to be, let me write it out here, and so we know lambda plus mu equals to 1, so we can write 3 plus mu equals to 1, therefore mu equals to minus 2. So we got the values of lambda and mu. Now we have to show that their values of the position vectors, they are exactly the same for L1 and for L2. So for lambda equals to 3, this position vector, now did they give any name for this point of intersection? They intersect, they didn't give any name, so let's just write it out as it is. So for lambda equals to 3, I can write minus 9 plus 2 lambda means 2 3 is 6. 6 minus 9 is minus 3. So this is going to be minus 3i. The next one is going to be 3. So this is going to be plus 3j. The next one is going to be 10 minus lambda. So 10 minus 3 is 7. So plus 7k. So lambda equals to 3 is going to be minus 3i plus 3j plus 7k. Now if mu equals to minus 2 also matches with L2 and L1 and L2 matches, then it means they intersect. So when mu equals to minus 2, so 3 minus 3 to the 6, so 3 minus 6 is minus 3. So far so good. And 1 minus mu is minus 2. So 1 minus minus 2 is 1 plus 2. So that is 3. So plus 3j. And finally 7 minus 2 3s are 2 5s are 10. So 17 minus 10 is plus 7. So we can write hence the lines intersect at, now do we have to write down the answer in position vector format or as a point? Position vector of their points. So it has to be in the ijk format. So hence the lines intersect at minus 3i plus 3j plus 7k. Question number B, we have to show that L1 and L2 they are perpendicular. That means the direction vectors, their dot product has to be 0. Remember, this is the rule. If two lines are perpendicular, that means there is 90 degree between them. So this has to be 90 degree. So here what it means is that cos 90 degree. So cos 90 degree is 0. So the dot product has to be 0. So what we have to do is we have to take the direction vector and show that the dot product is 0. So direction vectors are the ones in bracket. Here this is lambda, so this is the direction vector, and this is mu, so this is the direction vector. So dot product means multiplying the coefficient of similar directions. So coefficient of I multiplied by the coefficient of I plus coefficient of j multiplied by the coefficient of j plus coefficient of k multiplied by the coefficient of k. That's what dot product means. So let's do this. So question number B. So the direction vector of, by the question, so the dot product is for L1 2i plus j minus k dot 3i minus j plus 5k. So what we get here is 2i into 3i is 2 into 3. We don't have to write the I, plus coefficient of j is 1 and coefficient of this j is minus 1 plus coefficient of k is minus 1, coefficient of k is 5. So this is going to be 6 minus 1 minus 5. 6 minus 5 is 1 minus 1 equals to 0, and you write since the dot product, another name is the scalar product, dot product is 0, the lines are perpendicular. That's it. The next question, we have to show that a point lies on L1. Now to show that a point lies on L1, you have to remember every value of lambda represents an individual point. So if this is a point, so the coefficient of I and the coefficient of j and the coefficient of k, it's like a point of intersection with the position vector of A. The position vector of A means OA. So the values of lambda that we find for this has to match. So remember, if a point lies on a line, then the values of lambda must be equal for every single coefficient. That is the rule. So it's like a point of intersection. So let's write L1 all over again. So for question number C, let's write L1 all over again as the point of a position vector. So this is going to be minus 9 plus 2 lambda I. Then this is going to be 0 plus lambda j. and this is going to be 10 minus lambda k, and the position vector of A is OA, and OA is given as 5i plus 7j plus 3k. In order for this to work, we have to find the lambda using point of intersection rule. I equals to I, j equals to j, j equals to 3, j equals to this, k equals to k. And if the three values of lambda match, that means it's exactly one point that lies on this line. So for I equals to I, we get minus 9 plus 2 lambda equals to 5. So therefore 2 lambda equals to 5 plus 9 is 14. Therefore lambda equals to 7. So the other two has to match. So for j equals to j, what we get here is 0 plus lambda equals to 7. That means lambda equals to 7. So for k equals to k, we get 10 minus lambda equals to 3. Therefore 10 minus 3 equals to lambda. That means lambda equals to 7. So you write since lambda equals to lambda equals to lambda, the point A lies on L1. That's it. Question number D is not a vector question. A vector question is find the equation of a vector, find the point of intersection, find the angle between two lines. This is a basic geometry question. So the basic geometry question is the point B is the image of point A after reflection in the line L2. So it might not be clear at first, but if you see what information you have so far, then it would become clear. So let's write down the information that we have so far. The first thing that we know, we have L1 and L2 and they intersect. So for question number D, the first information we have, this is L1, this is L2, and they intersect at a point, and the coordinates are minus 3, 3, 7. That's question number A. That's what we know. The second information that we know, L1 and L2 is 90 degree. That's the second information that we know. The third information we know that there is a point A that lies, let me write it down here, and the point A has coordinates 5, 7, 3. So let me read the question again. The point B is the image of A after reflection in the line L2. So if this is the mirror, remember what happened. This is a basic concept of basic geometry. If you have a mirror and if this is the object and this is the image B, that means this distance and this distance has to be same. The distance from the object to the mirror is equal to the distance of the mirror to the object, to the image. So you have to understand. So this becomes the midpoint. So I don't know the x coordinate or y coordinate or z coordinate of B. So let me write down the midpoint of AB. So write it down like this: midpoint of AB. So we use the basic geometry rule: x coordinate plus x coordinate divided by 2. So it's the average, so x1 plus x2 by 2. So this is going to be x plus 5 by 2, comma, y coordinate is y coordinate plus y coordinate by 2, y plus 5 by 2, comma, z coordinate plus z coordinate by 2. So this is going to be z plus 3 by 2. So that's the midpoint. But we already know the midpoint is the point on the mirror. So this is the mirror and this is the midpoint. So this is going to be, so we know midpoint of AB is also equals to minus 3, 3, 7. So we can say this is equals to this. So x plus 5 by 2 equals to minus 3. That makes it x plus 5 equals to minus 6. Therefore x equals to minus 11. And so the coordinates of B is going to be minus 11, minus 1, and 11. So the mark schemes here. So we have this. Remember that this is the column vector format. It can be written as ijk or it can be written as column vector. Both are valid. So when we compare I, we get this equation. When we compare j and this, we solve the simultaneous equation, and the point of intersection we get is minus 3i plus 3j plus k. So this is correct. The next one that we have, question number B, the dot product has to be 0, and this is how you take the direction vectors and you do the dot product is 0. They did it in the column vector format. That is fine. They wrote way 1, so it can be done in a number of ways. Now the next one is we have to show that the three values of lambda is 7. So lambda equals to 7 for all three equations. The conclusion of this equation, it's better if you mention it so that all three values of lambda is equal. Now question number D, we use the midpoint, and using the midpoint we get minus 11i minus j plus 11k. The examiner's report says that in part A, most candidates were able to set up and solve the three equations correctly. Some candidates either did not realize that they need to perform a check for consistency or perform this check incorrectly. A surprising number of candidates did not follow the instruction in the question. This is a common mistake. When you're asked to find the position vector, you have to write it down in the IJK format. You have to remember that. You cannot just write it as a point. In part B, a majority of candidates realized that they need to apply the dot product formula on the direction vectors of L1 and L2. Many of these candidates performed the correct dot product calculation, but not all of them wrote a conclusion. It's important to write the conclusion. That means, since the dot product is 0, the lines are perpendicular. This is important. Now in part C, a majority of the candidates were able to prove that A lies on L1 either by substituting lambda equals to 7 into L1 or by checking the substitution. So it's a good idea to find the values of lambda for all three. There was a failure by many candidates to see the link between part D and the other three parts. This is essential. When you do at the end of the question, it might not be a vector question, but it would be connected to the other question. So you try to follow the story, and that's why. So when they say by many candidates, they're talking about a lot of people. So try to follow this instruction. The most common error of those who attempted this was to write B as this. Those candidates who decided to draw a diagram usually increase their chance of success. So it's a good idea when you do the sum, try to follow the story and try to do this. And remember, this is a question that is not a concept of vector, but rather a concept of basic geometry, how that works.